Okay. So good afternoon.
Good afternoon.
Good afternoon,
Good
sir.
afternoon.
Good afternoon. Good afternoon to everyone. Okay. Thank you. So today we will discuss first the problems involving del square. First problem. If f of z is an analytic function, analytic function of z, prove that dou square by dou x square plus dou square by dou y square. Actually, this is what? Del square. So you know that into modulus of f of z whole square equal to 4 times modulus of f dash of z whole square. Or in short form, you can tell del square of modulus of f of z whole square is equal to 4 times modulus of f dash of z whole square. Okay. So how to prove? Okay. So the idea is, so first you should take the left hand side. Okay. Okay. What is f of z? F of z equal to u plus iv. Okay. Modulus of f of z equal to what? Is
Square
equal
root
to
of u square.
Root of u square plus u
yeah, root of u square plus v square. So if you square this, because here we have square, modulus of f of z whole square, that is u square plus v square. Okay. So first you should differentiate by dou okay dou square, sorry, first dou by dou x of, because here what, dou square by dou x square of. So first you should differentiate this one with respect to x, and then second derivative, that is a dou square by dou x square of same thing. Similarly, dou by dou y of u square plus v square, and then dou square by dou y square of u square plus v square. So that is the left hand side. Okay, and then you should know what is modulus of f dash of z. So what is f dash of z? CR equation, the derivation of CR equation, equation number 1. You can check ux plus I vx. Okay, wow. So what is modulus of f dash of z? Root of ux square plus vx square. So you have square. Square means root is eliminated. So you have 4 times, and then whether you can check it, both of them are equal. That's all. Proof is over. So this is the idea of the proof. Now we will do it. So solution. So let us take f of z equal to u plus iv be the analytic function of z. So then modulus of f of z whole square. Okay, modulus of f of z whole square is what? u square plus v square. Okay, so I call this is 1. Similarly, we know that f dash of z. What is f dash of z? Ux plus I Vx. So again, this is from we got from here equation derivation equation number 1. So modulus of f dash of z whole square, that is equal to ux square plus vx square. So this is equation number 2. So now I am going to differentiate equation 1 uh, partially with respect to x. Okay, differentiate differentiate 1 with respect to partially with respect to x, partially with respect to x twice we get. So first time I need to differentiate, it is dou by dou x of dou by dou x of left hand side is what, modulus of f of z whole square. So if you differentiate the right hand side with respect to x, you'll get what, 2u into dou u by dou x plus 2v into dou v by dou x. So 2u into dou u by dou x plus 2v into dou v by dou x. Okay, this is first time. If I differentiate second time, dou square by dou x square modulus of f of z whole square is equal to, now now we should apply UV method. Okay, so take 2 commonly, okay, so u into, if you differentiate ux with respect to x, you'll get uxx plus you should keep this ux, and if you differentiate this u with respect to x, you'll get what, ux again. Similarly, v into vxx plus vx into vx. So I took 2 commonly. Now you can write like this. This is equal to 2 into, you can, I will group these two. Okay, u into uxx plus v into vxx. Okay, plus 2 into, now I am grouping these two, remaining ux square plus vx square. Okay. Similarly, this is actually what? This is a dou square by dou x square of modulus of f of z whole square. Okay, so we will give some equation number. So this is equation number 3. Similarly, dou square by dou y square of mod f of z whole square equal to, just replace x by y, you will get the answer. So u into u y plus v into v y plus, sorry, plus 2 into uy square plus vy square. I call this is equation number 4. Now add 3 and 4. I will write in the, I will try to write here, because then only I can easily write. I can't write all the terms here. Okay. So dou square by Okay, adding 3 and 4, so 3 plus 4 implies left hand side is what? Dou square by dou x square plus dou square by dou y square of mod f of z whole square. This is the left hand side. Right hand side, you should add like this. You should add these two terms first. So if I take these two, then you have what? I will take 2u common. Remaining is what? uxx plus uyy. So 2u into uxx plus uyy. Similarly, if I add these two, 2v into vxx plus vyy. And then remaining 2 into ux square plus vx square plus uy square plus vy square plus 2 into ux square plus vx square plus uy square plus vy square. I call this is equation 5. I think now we know the one property. If f of z is analytic, then the real part and the imaginary part are satisfies the Laplace equation. Okay, and the real and imaginary parts are harmonic function. Whether we proved that the property already, is it correct? Since
Yes, sir.
okay. So since u and v are harmonic functions, so uxx plus uyy equal to 0 and vxx plus vyy equal to 0. Okay, now and also okay, so this is 0, this is also 0. Okay, also by CR equation, what is CR equation? Ux is equal to Vy and Vx is equal to minus Uy. Okay. So now apply these conditions in equation 5. So 5 implies left hand side is what? Dou square by dou x square plus dou square by dou y square of mod f of z whole square. So this is equal to 2u into 0 plus 2v into 0 plus 2 into ux square plus vx square. Instead of uy, I will replace by minus vx whole square. Instead of vy, I will replace ux whole square. So now the right hand side is 2 times ux square. Again here have okay, right, vx square plus vx square plus ux square. Here we have 2ux square plus 2 vx square. Should take 2 commonly. So 4 times ux square plus vx square. So you have the left hand side. What is the left hand side? Okay, so 4 into ux square plus vx square. Okay. Now, therefore, so dou square by dou x square plus dou square by dou y square of mod f of z whole square equal to 4 times, what is this, ux square plus vx
Sir,
square. Yeah,
sir, on the equation 2, you left side square, sir.
equation 2. Yeah, I think I missed. Okay, thank you. What is your name? Shilava.
Santosh.
Santosh. Okay, Santosh. Thank you, Santosh. Okay. Yeah, because now I am searching for this equation. Okay, because right hand side I have what, ux square plus vx square. So modulus of f dash of z whole square. By equation 2. Whether please write. Okay. So next problem number 2. So I want to check the Virarajan book. Please write. So we proved a example uh, 3.13 and then 3.14. So the statement is what? Okay. If f of z equal to u plus iv is a regular function. You know what is regular function? It's the same as analytic function. Okay. Prove that del square of mod log f of mod del square of log of mod f of z equal to 0. Okay. So I will cut only the statement. We will prove. So this is the important result. These two results are uh, important results. Okay. So proof solution. So del square of mod f of z. Okay. So first, what is f of z? Let f of z equal to u plus iv. You start f of z equal to u plus iv be a analytic function. So okay, then modulus of f of z. what is modulus of f of z? Is equal to root of u square plus v square, or you can write this is equal to u square plus v square whole power u square plus v square whole power half. So the remaining part you should differentiate del square. You should operate del square on mod f of z. Yeah. So first I'm going to find what dou by dou x of okay, since it's mod f of z. So before that, take log, because here have log. Log of mod f of z is what? Log of mod f of z equal to 1 by 2 into log of u square plus v square. 1 by 2 into log of u square plus v square. Okay. So now, first to differentiate this equation with respect to x partially. So dou by dou x of log of mod f of z. Okay, so that is equal to, if you differentiate this 1 by 2 log, if you differentiate log of x, you get 1 by u square plus v square, and if you differentiate u square plus v square, you will get what? 2 into 2u into ux plus 2v into vx. Okay. So now you can take this 2 commonly and cancel out. So you will get ux plus vx divided by u square plus v square. So left hand side dou by dou x of log mod f of z. Okay. So now again I am going to find dou square by dou x square of log f of z whole square. So just a partial derivative. Okay. So u by v method again. U square plus v square whole square should keep u square plus v square. To differentiate the numerator, we have what? U into uxx. Okay, u into uxx plus ux into ux. That is ux square. I will write plus v into vxx plus vx into vx. That is vx square. Okay, and then I don't have a space here, that's why I put minus. Okay, minus here. Okay, minus. You should keep the numerator. Numerator is what? U into ux plus v into vx. To differentiate the denominator, you get what? 2u ux plus 2v vx. Close the bracket, and then that's all. Okay. So now you can write this is equal to, you can group these two, and similarly you can group these two. So here you have u square plus v square into u into uxx plus v into dxx plus ux square plus vx square. And then from here I took 2 commonly. If I took 2 commonly, remaining is what? Minus 2 into UUX plus VVX. Here also you have what? UUX plus VVX. So that is UX plus VX whole square. The denominator is U square plus V square whole square. Okay. So now this is actually dou square by dou x square of log of mod f of z. So okay. So you call the equation number 1. I think I don't give any number, so that's why 1. Similarly, please tell what is dou square by dou y square. Dou y square of
plus v square
yeah, please put it right down now. Log mod f of z. Now you can
u square plus v square
u square plus v square. Okay.
into uyy
Okay. U into uyy
plus vvyy
plus vyy. Okay.
plus uy square plus vy square
uy square plus vy square. Okay.
minus of 2
Minus 2
uuy plus vvy the whole square
uuy plus vy whole square.
divided by u square plus y square the whole square
U square plus v square whole
the
square.
whole square.
Thank you, Varshi. So you call this is equation 2. Now I am going to add equation 1 and 2. 1 plus 2 implies left hand side is what? Dou square by dou x square plus dou square by dou y square of log mod f of z, which is equal to, okay, so first u square plus v square, okay, so u square plus v square into this term, okay, 1 2 3 4 terms here we have. Similarly I have what? U square plus v square. Here also I have 4 terms, so that's why I took commonly u square plus v square. So 4 plus 4 8 terms. Now I am going to write. So first I think you have u into uxx, and then you should write this term correspondingly. Okay, first you should write whatever it is here, v into vxx plus vx square plus vx square and then plus u into uyy plus v into vyy plus uy square plus vy square. So and then I will write this term minus 2 into similarly I will write this term. So minus 2 into u into ux plus v into vx whole square minus 2 into uy plus vy whole square whole divided by u square plus v square whole square. Okay. So now this is 0 because if you take u commonly, uxx plus uyy is 0, If you take v commonly, vxx plus vy equal to 0. Remaining here you have what? Ux square plus uy square plus vx square plus vy square. Okay, and then we also have this term. Okay, let us see what happens. Now the numerator, I will write u square plus v square into u into uxx u into, I took these two terms, into uxx plus uyy plus v into vxx plus vyy okay, plus ux square, uy square, vx square plus vy square. Plus ux square plus uy square plus vx square plus vy square. Close the bracket, and then these two minus 2 is common. Okay, then a square plus b square plus 2ab. Here also you have a square plus b square plus 2ab. Totally 6 terms I am going to write after taking minus 2. After taking minus 2, you have u square into u square y, sorry, here, yeah, u square into ux square plus v square into vx square, vx square plus 2 uv ux into vx. Okay, and then plus u square into uy square plus v square into vy square, v square into vy square plus 2 times uv into uy into vy. Close the bracket, and then denominator is u square plus v square whole square. Now this is equal to, so we know that this is 0, this is 0, so directly I will write u square plus v square u into 0 plus v into 0, okay, plus ux square plus uy square plus vx square plus vy square, okay, minus 2 into can take commonly, okay, first add these two, okay, here u square is common, so if I take u square, remaining you have what, ux square plus uy square Similarly, if you take v square common, vx square plus vy square so here, okay, so just keep as it is. Even the 2uv is common here. Okay, can take
So
2u.
that will become 0 now, sir.
Which one,
2
Sheila?
uv into u.
2uv into using CR equation. Huh?
Yes, sir.
Yeah, you are right. You are right. But okay, I will write and then I will make it 0. Okay, you are right. So ux into vx, okay, plus uy into vy. close the bracket, and close this square bracket. So now the numerator you have what? The numerator you have, okay, I forgot the denominator. So u square plus v square whole square. So it is equal to u square plus v square into the numerator you have u square ux square plus uy square plus vx square plus vy square. Okay, wow. ux square plus uy square plus vx square plus vy square. Okay, and then what about this? Here, what is common? Here, I think nothing is common. Minus 2u square. Okay. So actually, this is 0. What about how to do it this one?
So we can make vx square uy square and vy square ux square, and then take u square v. Take the u square plus v square common.
Okay. Yeah, using CR equation again, you are telling, huh?
So
Okay. So you should keep ux square plus uy square as it is. I will write minus 2. Okay, wow. Close the bracket. Minus 2. Okay, I will write here. Minus 2 into u square. U square into ux square plus vx square. Okay. U square into ux square plus vx square. Okay. Plus v square into. So now using CR equation, what is vx?
minus 2.
minus uy square.
Minus uy, yeah. Okay.
You can write vy as ux in that side. So it will be ux square plus
So
vx square.
here I need to change. Yes, you are right.
So
Everything
now
I
that-
need in terms of
So
x.
that is correct, sir. The next one, v square
Here,
into
u square into
v square into vx square plus ux
yeah,
square.
v square into yes vx square plus you are changing vy is what minus ux
Correct. Yes, sir.
minus ux. So
So
minus
plus
ux square. Yes, correct. And then similarly here what? Plus 2uv plus 2uv into ux into vx. Okay. Uy is what? Minus vx. Uy
Yes,
is minus vx. Vy is ux. Yes. So this is also 0. And here ux, this is actually ux square plus vx square. This is also ux square plus vx square. That is common. So you take these two are common, then you have what? U square plus v square. So which is equal to u square plus v square. Okay, into here also you can do what?
into ux square plus vx square.
Ux square and the uy instead of uy you can change what minus vx minus vx whole square by using CR equation plus vx square. Instead of vy you can replace by ux square minus 2. Okay, I forgot the denominator. Okay, Otherwise, can I put here like this slash
Yes, sir.
a square plus b square whole square? Okay. So now I think I wrote this one and then minus 2 into ux square plus bx square is common. Remaining you have u square plus b square. This is 0 divided by u square plus b square. Actually, I need to prove that is equal to 0. Okay. Yes. So this is v. You have 2 times ux square plus 2 times what? Vx square. So I think this is the numerator is same. So is equal to u square plus v square into 2 times ux square plus 2 times ex square minus 2 times u square plus v square into ux square plus vx square. So divided by u square plus v square whole square. So you can directly write 0 because if you take 2 commonly and then so now the final answer is del square of log mod f of z equal to 0. Okay. So now I'll go to the third problem. I think now you catch the idea because you are telling the answer and also you are telling the mistakes. Okay. I think you know how to do it. So for the first two subdivision, later I will give one more method. Okay, not now. Third one, maybe the other method is a little bit easier. If you want to follow, you can follow that method also. So del square of up, okay, del square of up equal to p into prove that del square of up equal to p into p minus 1 into u power p minus 2 into modulus of f dash of z whole square. So if you know the idea, okay, you can try independently. So usually in the classroom, I don't solve all the problems. So suppose if you have 5 problems, then I will do 3, remaining 2. Okay, I am expecting the students should solve the problem, but here it is not possible. Let f of z equal to is Darren Rhodes is watching this video? No. He's asking. Yes.
So you asked something, sir.
Yeah, Rhodes. Darren Rhodes. Actually, I think he's he's asking a question. Something in the WhatsApp. That's why I want to talk with him. So actually, I forward the message. Okay, I don't know about that Harvard University. Okay, I think sir, where we supposed to register for the courses. So if any one of them knows, please post in the group because I don't know.
Sir, it will be available in YouTube or you can go
Website,
to. Yes, sir. It will be available in YouTube also, sir.
YouTube also. Okay, okay. Thank you, Sheila.
Yes.
If it is available, that okay. If possible, you can share that message in the group, or you can send to that guy. Okay.
Okay, sir.
Thank you. So let the f of z equal to u plus iv is an analytic function. So now, okay. So here I have u power p of u power p. So first I will find that dou by dou x of u power p is what? P into u power p minus 1 into ux. Next, second derivative, dou square by dou x square of u power p equal to, if you differentiate again, you'll get what? P in uv method, so keep p is common, u power p minus 1 into, if you differentiate u, you'll get uxx plus, so keep ux, and if you differentiate u power p minus 1, you have p minus 1 into e power p minus 2 into ux. So that is equal to p into u power p minus 1 uxx plus p minus 1 into u power p minus 2 into ux into ux square. So similarly, this is actually dou square by dou x square of u power p, and I need dou square by dou y square of u power p, that is equal to p into u power p minus 1 uyy plus p minus 1 into u power p minus 2 uy square. You call this is 1, you call this is 2, adding 1 and 2, left hand side is dou square divided by dou x square plus dou square by dou y square of u power p. So if you add these two, you get what? So if you add these two, first I am adding this. So p into u power p minus 1 is common. P into u power p minus 1 is common. Remaining you have uxx plus uyy. And then here, if in these two terms, p into p minus 1 into u power p minus 2 is common, plus p into p minus 1 into u power p minus 2 is common. Remaining you have ux square plus uy square, uy square. So this is 0, okay. So this is 0, and the remaining you have what? P into p minus 1 into u power p minus 2 u power u power p minus 2 into ux square. By using CR equation, uy is what? Minus vx square, because I want to write in terms of f dash. So p into p minus 1 to u power p minus 2 into ux square plus vx square. So this is, you know, that f modulus of, okay, this is p into p minus 1 to u power p minus 2 into modulus of f dash of z whole square. So since f dash of z equal to ux plus ivx. So from this, so you can find modulus of f dash of z. So left hand side is what? Dou square by dou x square plus dou square by dou y square of u power. Third one is over. Fourth one, prove that L square of mod f of z whole power p equal to e square into mod f of z whole power p minus 2 into modulus of f dash of z whole square. So this question also came one time in the examination. This is a little bit lengthy, but you can easily understand. Okay, so solution. So let us take f of z equal to u plus iv is an analytic be an analytic function. Okay, now what is modulus of f of z whole square? Modulus of f of z whole square equal to u square plus v square. Okay, wow. Okay, now actually I need modulus of f of z whole power p I need. So modulus of f of z equal to u square plus v square whole power half. Okay, so this implies modulus of f of z whole power p is equal to u square plus v square whole power p by 2. Okay, so now I need to find the first dou by dou x of mod f of z whole power p. So that is equal to dou by dou x of u square plus v square whole power p by 2. Okay, so if you differentiate this, so p by 2 into u square plus v square whole power p by 2 minus 1 into 2u in 2u ux plus 2v dx. Okay, yes. Now you can take 2 commonly from this, you can cancel out. So p into u square plus v square whole power p by 2 minus 1 into u into ux plus v into dx. So now this is actually the first derivative. First derivative. Now second derivative. Dou square by dou x square of dou square by dou x square of mod f of z whole power p equal to, that is dou square by dou x square of mod f of z whole power p is what? U square plus v square whole power p by 2 okay. So I will write here. Okay, I am going to differentiate this function once again. So please tell. So here p by 2 is constant. U square plus v square whole power p by 2 minus 1 is of have this function. Okay, so I think you should consider this because I already cancelled 2 and 2. So this is u, this is v. Okay, well. So please check it carefully. So p into u square plus v square whole power p by 2 minus 1 p by 2 minus 1. So if you differentiate this function, you'll get what? U into uxx, u into uxx plus ux into ux, that is ux square, plus v into vxx plus vx into vx or vx square. Okay, and then p into, I should keep this is, and now I'm going to differentiate this function. So plus p into u into ux plus v into vx. If you differentiate this function, p by 2 minus 1 into u square plus v square whole power p by 2 minus 2. P by 2 minus 1 into u square plus v square whole power p by 2 minus 2, and then you need to differentiate u square plus v square once again. You'll get 2u ux plus 2v vx. Okay, now this is equal to p. Okay, yes. So p into u square plus v square, p minus 2 divided by 2. Okay, and then you can group these two, plus into u into uxx. Here have vxx. So there is no need to group now. Should keep as it is. uxx. Okay, well, uxx plus ux square plus v into vxx plus vx square. Okay, plus here you have 2 is common, so that's why I took this 2 into p, and here what? P minus 2 divided by 2 to ux plus vvx. Here also ux plus vvx. So that is ux plus vvx whole square, because I already took 2 commonly. Okay, into u square plus v square, u square plus v square whole power p minus 4 by 2. Okay, now yes, right here. So p into u square plus v square whole power p minus 2 divided by 2 into uxx plus v into vxx plus ux square plus vx square. 2 gets cancelled, plus p into p minus 2. Okay, p into p minus 2 into u square plus v square whole power p minus 4 by 2 into what? U into ux plus v into vx whole square. Okay, so actually this is nothing but dou square by dou x square of mod f of z whole power p. I call this is equation 1. Similarly, what? Dou square by dou y square. Dou square by dou y square of mod f of z whole power p, okay, equal to dou square by dou y square of v square plus v square whole power p by 2 v square plus v square whole power p by 2, which is equal to, so we have a very lengthy term, but there is no other way we need to write. So p into u square plus v square whole power p minus 2 divided by 2 into uyy plus vvyy. Okay, uyy, yes, plus vvyy plus uy square plus vy square. Actually, this one you can write what? This one ux square plus vx square is what? Modulus of f dash of, yeah, f dash of z square. Yeah, then I can write that one instead of, otherwise I have a very big term. So ux square plus vx square is modulus of f dash of z whole square, okay, into okay, now I think yeah, here bracket, I'll put bracket here, yes. So then you get here also what? Modulus of f dash of z whole square, close the bracket. So I think I finished the first part. Remaining we have p into p minus 2 plus p into p minus 2 into u square plus v square whole power p minus 4 by 2 into ux. Okay. Here we have what? ux plus vx whole square. ux plus sorry, if it is x means here y, uy plus vy whole square. Okay. So now this is 2. Now adding 1 and 2, 1 plus 2 implies left hand side is what? Dou square by dou x square plus dou square by dou y square of mod f of z whole power p. So I think the first part, what is common? You can take p into u square plus v square whole power p minus 2 by 2. So if you take here u into uxx, here what? U into uyy. So I will write p into u square plus v square. V square into u, okay. If I take this is common, u into uxx plus uyy. Yeah. I think this is common. So u into uxx plus uyy. Similarly, plus v into what? p into vxx plus vyy. Okay, here I have f dash of modulus of f dash of z whole square. Here also you have modulus of f dash of z whole square. So 2 times modulus of f dash of z whole square, close the bracket, and then plus p into,
Sir,
please do.
sir, u square plus v square whole power p minus 2 will come up. Sir.
Sorry.
Sir, first starting p into u square plus v square whole power p minus 2 by 2 will come on.
Oh, okay. I missed the whole power p minus 2 by 2.
Yes, sir.
Yes. Okay, thank you, Shiva. Whole power p minus 2 divided by 2. So close the, I think now it is correct.
Yes, sir.
Okay. Okay. Now plus p into p minus 2. P into p minus 2 into u square plus v square whole power p minus 4 by 2. U square plus v square whole power p minus 4 divided by 2. Okay. So now expand this a square plus b square plus 2ab. So totally here you have 3 terms. So you have u square, ux square, okay, plus v square plus vx square. V square into vx square plus 2uv into 2uv into ux into vx plus here again u square into uy square plus v square into vy square plus 2uv into uy into vy. So close the bracket. Okay. So now this is 0. This is 0. Okay. Only I have this portion. Okay. So 2p into u square plus v square whole power p minus 2 by 2 into modulus of f dash of z whole square. Two p into u square plus v square into okay 2p u square plus v square whole power what p minus 2 divided by 2 into modulus of f dash of z whole square. Okay. Now here what we can do the second part. Here you have p into p minus 2 into u square plus v square whole power p minus 4 by 2. Okay, I think here we need to use CR equations. Okay, if we use CR equation, this is 0. Okay, the last two terms. Here also, if I use the CR equation, convert uy and vy in terms of ux and vx. Okay, so please tell only this portion plus p into p minus 2 into u square plus v square whole power p minus 4 by 2 into u square into ux square plus v square into vx square. Okay, and then plus 2uv plus 2uv ux into vx, ux into vx. Okay, if you use CR equation here, uy is what? Minus vx. So u square into vx square. Similarly, v square into uy square. Okay, ux square. V square into ux square. V square. Sorry, v square. V square into ux square. And then up here, I think minus 2uv. I will write directly minus 2uv. Okay, uy is minus vx, so minus vx, and uy is sorry, vy, yeah, vy is ux. So you can cancel these two. So now this is equal to 2 times p into u square plus v square whole power p minus 2 divided by 2 into mod f dash of z whole square, here plus p into p minus 2 u square plus v square whole power p minus 4 divided by 2. Okay, if this is actually what? If I take u square commonly, remaining we have ux square plus vx square. Similarly, if I took commonly v square, you have what? ux square, ux square plus vx square. So again, it take commonly ux square plus vx square. So 2 times p into u square plus v square whole power p minus 2 divided by 2 modulus of f dash of z whole square plus p into p minus 2, okay, into u square plus v square whole power p minus 4 by 2. So if I took u square plus v square commonly, sorry, if I took ux square plus vx square commonly, you have u square plus v square. So this is what modulus of f dash of z whole square. This is modulus of f dash of z whole square. Here I have power 1. So you should group these two. So 2p u square plus v square whole power p minus 2 divided by 2 into modulus of f dash of z whole square plus p into p minus 2 remaining you have what? U square plus v square whole power p minus 2 divided by 2. So u square plus v square whole power p minus 2 divided by 2 into f dash modulus of f dash of z. Modulus of f dash of z whole square. So in these two, what is common now? Okay, I think P is common. Uh, okay, U square plus V square whole power P minus 2 divided by 2 is common. Okay, and the modulus of f dash of z whole square is also common. Remaining here, you have 2. Here you have P minus 2. So final answer. So P square into modulus of f dash of z whole square. What is u square plus v square? V
Mod f
square,
of z
Z.
yeah,
whole square.
actually f of z equal to u plus iv. So then mod f of z equal to uh, okay u square plus v square whole power half. Okay, that is a modulus of f of z is root of u square plus v square all whole power half. Now here you have u square plus v square whole power p minus 2 divided by 2. So implies this is nothing but modulus of f of z whole power p minus 2. Okay, so the proof is over. Check the time, 4:30.
So can you give us 2 minutes break, sir?
Sorry,
So could you give us 2 minutes break, sir, so we can
reach.
refresh?
Okay, no problem. So I also have some tea and then I will join. So most welcome. Okay. So even if it can take 5 minutes, no problem. Okay, I will start exactly now. I'll start again uh, 4:40. Okay, now
Yes.
4:37.
Okay, sir. Thank you.
Okay, okay.
Sir, when we have to join again, sir?
தெளிவாயிட்டீங்களா? டிஸ்க் ஆயாச்சா?
Yes, sir.
Yes, sir.
ஓகே. ஸோ
Yes, sir.
ஓகே. ஸோ இன்னும் ஒரு 2 மணி நேரம் எடுக்கலாம் நினைக்கிறேன். அவ்வளோ எடுக்க மாட்டேன். ஓகே. So now, so I think subdivision. This is problem number what? 3 or 4, Amma? I don't know. Okay. 4.
Sir, and sir, the
Please.
last conclusion, sir, f dash of z.
Shiva, please. Your voice is a little bit low. Okay, please tell. Please tell.
Sir, p square into f of z p minus 2 only, no, sir.
It should be f
P
dash
minus
of the whole square.
f of here f dash of is da.
Yes.
Yes.
sir.
Yes. Yeah, you are right. F dash of modulus of f dash of is the whole square. Here what? Modulus of f of is the whole power p minus 2. Okay, now it is correct, Shiva?
Yes, sir, correct.
Okay, thank you. Okay. So next problem, I think problem number 5. I will go to the next page. Prove that argument of prove that del square of argument of f of z equal to 0. So solution. So now you know that f of z equal to e plus iv. So argument of f of z equal to tan inverse of v by u. Okay. So now I need to find del square of this. So first I will find dou by dou x. Dou by dou x of argument of f of z. So if you differentiate this function tan inverse of x with respect to x, you will get 1 by 1 plus x square. 1 by 1 plus x square is what? V square by u square. And if you differentiate v by u in u by v method, u square, keep u, and vx minus v into ux. Okay. So this is equal to u square plus v square. This u square is going to numerator. So u square divided by u square plus v square into u vx minus v ux divided by u square. So u square gets cancelled. So dou by dou x of argument of f of z equal to u vx minus v ux divided by u square plus v square. So this is equation 1. Similarly, okay, still I need to find the second derivative. Okay, dou square by dou x square of argument of f of z. So u by v method again. So that is equal to so dou by dou x of argument of z is what? U vx minus v vx u vx minus v ux divided by u square plus v square. I need to differentiate this with respect to x. So I put equal to here, and u square plus v square whole square. So keep u square plus v square, and if you differentiate the numerator, you will get what? U into uv method, u into vxx plus Vx into Ux. Okay, va? Minus minus V into Uxx, again minus Vx into Ux into Vx. Close the bracket, and then minus, keep the numerator. What is the numerator? U into Vx minus V into Ux. If you differentiate U square plus V square, you will get 2U Ux plus 2V Vx. Close the bracket. Okay. So now you need to simplify further. U square plus V square. Okay. Vxx. I think yes. I will write like this: U square plus V square into I group these two. Okay. So if I group these two, you'll get what? U Vxx minus V into Uxx. Okay, va? And you can cancel these two. Ux Vx, Ux Vx. You can cancel these two. Okay. Now here 2 is common. Okay, va? 2 is common. Minus 2. Minus 2 into, if I multiply these two, you'll get what? U square into Ux into Vx plus UV Vx into Vx square. Okay, and then here minus UV into Ux square, and if minus V square into minus V square into Ux into Vx. Close the bracket. The denominator is U square plus V square whole square. So this is actually okay. Still, I want to simplify further. Okay, little bit. So U square plus V square into UVxx minus UVxx minus V Uxx. Okay. Here Ux Vx. Okay. You can take commonly these two. Okay. You can group these two. So Ux Vx, if I took commonly, you have what? Remaining U square minus V square. Similarly, if I take UV commonly, this is Vx square minus Ux square. Okay. So first minus 2 Ux into Vx. If I take Ux into Vx common, remaining U square minus V square. Plus, if I take UV common, Vx square minus Ux square. Okay, close the bracket, divided by U square plus V square whole square. So this is nothing but equation 1. Okay, equation 1. The left hand side, I will write argument of not argument of dou square by dou x square of argument of f of z. Argument of f of z equal to this. Okay, va? Equal to this expression. So similarly, dou square by dou y square of argument of f of z, which is equal to replace x by y. So I will write here u square plus v square into u v y y minus v into u y y minus 2 into uy into vy into u square minus v square plus uv into vy square minus uy square whole divided by u square plus v square whole square. So now we need to add equation 1 and 2 and get the answer. Okay, if you add equation 1 and 2, so u square plus v square is common here. If I should group these two, okay, if I group these two, vxx plus vyy 0. Similarly, if we group these two, uxx plus uyy 0. Okay, from here minus 2 is common. And here the first term u square minus v square is common, ux into vx plus uy into vy. Here uv is common, vx square minus ux square plus vy square minus uy square. So I can easily tell, but if I write, it is a little bit difficult for me, okay, because I need to go to the next page. So 1 and 2 implies dou square by dou x square plus dou square by dou y square into argument of f of z, that is equal to, okay, the numerator is u square plus v square is common, u square plus v square is common, okay, into u is, first I took u common, so u into vxx plus vyy minus v into these two, v into uxx plus uyy okay, that's all. This is over, and then minus 2, I took u square minus v square common, u square minus v square is common, remaining you have what, ux vx uy vy, ux vx plus uy vy, and here uv is common, so vx square minus ux square, vx square minus ux square, and then plus vy square minus uy square minus uy square. Close the bracket and then close the square bracket. So this is 0, this is 0. Since u and v are harmonic, okay, so okay, the denominator is what? Denominator is u square plus v square whole square okay. So this is equal to only I have this term minus. Okay, again this is also 0 by CR equation. Okay, so minus 2 into u square minus v square into ux into vx. Uy is minus vx, minus vx. Vy is ux plus uv. Okay, so I'm going to convert everything in terms of x. X okay, x பண்ணலாமா என்ன பண்ணலாம் இங்க பாருங்க. Vx square, okay, plus Vy square, okay, minus Ux square, minus common எடுத்தா minus Ux square plus Uy square. So please write, otherwise we will write because anyway it is 0, that's why okay, uv vx square minus ux square. So what is vy? Vy is minus vx. Vy is ux, sorry, Vy is ux. Okay, so ux square minus uy is minus vx. Okay, minus vx square divided by, I think this minus 2 is common for everything. Yes, this minus 2 is common for everything, divided by u square plus v square. So please tell the next line, which is equal to minus, yeah, this is 0. Ux vx, this is 0. Here also you can see that what ux square. Okay, I will write only this term, minus 2 into, this is 0, minus 2 into vx square minus ux square plus ux square minus vx square whole divided by u square plus v square whole square. Okay, so now it is equal to 0. So left hand side, dou square by dou x square plus dou square by dou y square of argument of f of z equal to 0. Okay, now problem number 6. Dou by, prove that. So the remaining problems are simpler problems. It's not this much lengthy. Prove that dou by dou x of modulus of f of z. Okay, modulus of f of z whole square plus dou by dou y of mod f of z whole square equal to modulus of f dash of z whole square. So solution. So let us take f of,
Wait, so once.
okay. So f of z equal to u plus iv. Okay, I need a mod f of z. So okay, mod f of z equal to uh, root of u square plus v square, and then I need to find dou by dou x of this function. So dou by dou x of mod f of z equal to, if you differentiate this, you will get 1 by 2 into root of u square plus v square. Okay, root x differentiation 1 by 2 root x. If you differentiate x, that is u square plus v square, you get what? 2u into ux plus 2v into vx. So if you take 2 commonly and cancel out, ux plus v vx divided by root of u square plus v square. So now I need actually square of this term I need. So dou by dou x of mod f of z whole square is equal to ux plus vx whole square divided by u square plus v square. I call this is 1. Okay, I call this is 1. So it's okay. So similarly, what is dou by dou e of mod f of z whole square? Dou by, similarly, dou by dou y of mod f of z whole square equal to uy plus vvy whole square. uy plus vvy divided by u square plus v square. This is 2. Add 1 and 2. So you'll get dou by dou x of mod f of z whole square plus dou by dou y of mod f of z whole square equal to, I think the denominator is same. You can add the numerator ux plus vx whole square plus uy plus vy whole square divided by u square plus v square. So here a plus b whole square formula, here also apply a plus b whole square formula. You'll get u square ux square plus v square vx square plus 2uv ux vx plus u square uy square plus v square vy square plus 2uv uy into vy. The denominator is u square plus v square. Okay, so now this is equal to, so if I take u square commonly here, you'll get what? U square ux square plus uy square plus from these two, if you take commonly v square vx square plus vy square. Okay, plus 2uv. I took commonly 2uv. Remaining is what? Ux into vx plus uy into vy. Actually, this is 0 divided by u square plus v square. So now I am going to apply CR equation. So now if I apply CR equation for uy, you will get what? Minus vx. So minus vx square is vx square equal to u square into ux square plus vx square plus v square into vx square plus uy is vx, sorry, this is vy, vy is ux square plus 2uv to ux into vx minus, again apply CR equation, uy is vx, uy is minus vx, uy is minus, and vy is plus ux. So divided by u square plus v square. So you can write just by CR equation, by the reason CR equations. So this is f dash of modulus of f dash of z whole square plus v square into modulus of f dash of z whole square. This is 0 divided by u square plus v square. So if you take modulus of f dash of z common, whole square common, remaining have u square plus v square divided by u square plus v square. So that is equal to mod f dash of z whole square. Proof is over. Now, okay. Seventh one. I think this is the last one. One more. That one I will give to you for practice problem. So prove that del square of mod a real part of f of z whole square is equal to 2 times mod f dash of z whole square. So let us take f of z equal to u plus iv, be an analytic function. Okay, so what is the real part of f of z here? U. Okay, so what is modulus of real part of f of z? Okay, whole square, that is u square. So there is no need to put modulus. Okay, just put okay, just we can take this is u square. So now del square, I need del square. So dou by dou x of u square. Dou by dou x of real part of f of z whole square, that is u square. So 2 into u into ux Similarly, dou by dou square by dou y square of u square is what? Okay, again you should apply UV method. U into uxx plus ux into ux into ux, that is 2 into uxx plus ux whole square. Okay, this is actually equation 1. Yeah. Similarly, sorry, this is dou square by dou x square. I think you also tired. That's why I don't give the where I will mistake this point out. Okay, so similarly, dou square by dou y square of u square. So that is equal to 2 times uyy plus uy square. Okay, so now this is 2. If you add 1 and 2, implies you get dou square by dou x square plus dou square by dou y square of modulus of real part of z actually. Okay, so or you can write that is u square first. Okay, u square, that is 2. If I took 2 commonly, you have what? Here you have uxx. So I took u commonly, so uxx plus uyy plus ux square plus uy square. Okay, this is nothing but this is 0, so 2 times ux square plus by using CR equation, this is what? Minus bx whole square, or by CR equation. So left hand side is nothing but dou square by dou x square plus dou square by dou y square of modulus of real part of f of z whole square equal to twice this is ux square plus bx square, or you can write this is 2 into modulus of f dash of x, sorry, f dash of z whole square. So proof is over, and you should try is a practice problem. 8th one, prove that imaginary part of f of z whole square. Okay, modulus of, I think here also you have modulus. Yeah, modulus. The same idea. So del square of modulus of imaginary part of f of z whole square equal to, let's say 2 times modulus of f dash of z whole square. So here it took u. Okay, wow. So imaginary part means what? V. So instead of u, replace by v. That's all. You will get the answer. So I think you can try this problem. So now time is 5:15. So I don't want to test your patience. So still I have so many problems, but I don't want to do it. So I think the problems involving del square is over today. So from Monday onwards, we will solve some more problem. So in the meantime, please go through Virarajan book. Okay. So again, I will repeat you. It is very difficult to cover all the problems. Even I can't cover all the example problems. Okay, but I can give the only some idea only. Okay, so uh, so you try. If you feel any difficulty, you can post in the group or you can contact me. So then I will tell. Okay, so if you tell where you find difficult, then I will clarify your doubts. Okay, so it's you need to try and uh, and you should work more. Okay, thank you everyone.
Sir,
If you have any doubt, you can.
sir,
Yeah,
these
please tell.
derivations can't be do by total differentiation concept, sir.
Uh, please tell Chaitanya.
Sir,
I
these
don't
derivations
understand
there, no, sir, by
what
total differentiation concept.
you are asking whether we can do by total differentiation or
Yes,
these
sir. In
things.
Fourier series we studied, no, sir, total differentiation method.
Yes, yes. But here we are studying partial derivatives. We are doing only del square. Okay.
Okay, sir.
Here del square is what? Dou square by dou x square plus in all the problems you have what? I think the last two problems it doesn't have a del square. Yeah, here also you have del square. And all the 8 problems del square is involved. That's why I gave the section name problems involving del square. Okay, Chaitanya, got it?
Okay, sir. Okay, sir. Thank you, sir.
Or your doubt is I think I understand your doubt. So if you don't get it, then you please call me and then we will discuss. Okay, thank you, Chaitanya.
Okay, sir.
Okay. And some of the students I watched your assignments. Okay, some of the students have done it very nicely, and I told only 10 questions you need to solve, but some of the students done it nearly 15 questions like this. So good. Okay, so I don't want to tell the name because still I want to. Uh, I am waiting for the remaining students' assignments. Okay. Okay. Good. Thank you. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.